So chapter 1-3 is all about solving equations. So here, first, let's look at some of the vocabulary. Where you have an expression is an open sentence with one or more variables. So an expression, you'll see the difference between that and an equation. An expression does not have an equal sign. An equation is an actual math sentence where you have two expressions that are equal. So you'll have that equal sign in an equation. So what is a solution? So any number that can replace one of the variables and then makes the sentence true would be a solution. So n is equal to 2 for this particular equation works out. Because if I replace the n with the 2, 2 times 2 is 4, 4 minus 1 is 3. So therefore, n equals 2 would be a solution. So there are some properties that we're going to be looking at having to do with, solving equations and so on. So the reflexive property, think of the word reflection. So the reflexive property tells us that if I have A, it is equal to A, right? So 2 is equal to 2, 7 is equal to 7. I know some of these may sound a little, too simplistic, but we do need these properties to do some of the operations we're going to be working on. So the symmetric property tells us that we have symmetry. And I placed this line here in the middle on purpose because if you think of your biology, you learn about bilateral symmetry. That means that on both sides, you have like kind of a mirror image. You see the same thing. And so we humans have a little bit of bilateral symmetry. We're not perfectly the same on our left side as our right side, but pretty much. So just think of that word like a symmetric. So that is what this property tells us, that, hey, look, if I have A is equal to B, then the B is equal to A. So the right side is equal to the left, same as the left is equal to the right. So another property is a transitive property. Think of transportation, where I take, if I have A is equal to B and B is equal to C, then therefore I can transport the A being equal to the C. So that is the transitive property. And then we have the substitution property, where if I have A equal to B, then I can replace A anywhere by whatever B is. So if X is equal to 5, everywhere I see an X, I could put the number 5 in its place. And you've done that before. That's just plain, substituting. All right, so then we have the addition and subtraction properties of equality, where if A is equal to B, then if you add some constant, some number to both sides, or subtract from both sides, then you should end up, with them being equal still. So if I have A equal B and I add a C to the left, then make sure if you do it to the right, then they're still equal to each other. Then we have the multiplication and division properties of equality, where C can't be 0. So if A is equal to B, then A times anything else that you add is equal to B times anything else that you add here. Same thing with division. If I take the left and the right side and divide them by the same number, they're still equal to each other if A and B were equal to each other to begin with. So just going to show you that you can, whatever you do to the left, do to the right. And same thing goes if you divide one side by a number, then do it to the other side. Everything is still equal. You have not changed anything. So now let's look at your packet 1-3, solving equations. So you've seen some of these vocabulary definitions already, and then you have some sample problems to practice with. So let's go ahead and look at this example 1, slide 15 here. So it says to write an algebraic expression to represent a verbal expression 2 less than the cube of a number. All right, so to be able to work on these type of questions, we have to look at word by word and start from the left to right. So 2 less than. Than is an important word, because if you see than, you flip. You don't start writing 2 less first, you write it after. So 2 less means I have to subtract 2, so I write it over here. Then this part I'm going to write over here. And it tells me to take the cube of a number. So what number is it? I don't know. It looks like here they're using x, so I'm going to use x too. And then it says a cube. To be cubed, you are to the third power, I'm sorry. So that would be x to the third power minus 2. So therefore, letter B is your answer. Now let's continue looking at some of these slides. They give you some more examples. So just for you to practice, you have the answers there to check your work. If you notice, the properties that I already mentioned are listed here. So just, do another quick review. It gives you some examples of the actual properties. So let's have a look at the actual guide and intervention. So here, just read the information that they give you and then try to do some of the problems. So let's go ahead and practice one of these here. I'm going to choose one that has like number 3 that has the word than again. So let's go ahead and look at that one. So remember that I mentioned anytime you see the word than, you flip. So this is going to go first. It's going to go over here, and the 7 less is going to go there. I see 7 less again, the less part. So I'm going to take away 7. And from what? Well, it says here 15 times a number. Anytime you don't know what a number is, you always put the letter x or some variable. So 15 times x, and here is the expression you are looking for. Let's continue looking at some of these. It says to write a verbal sentence to represent the equation. So remember that I see 35 less, so I'm going to write that first. 35 less than, because remember that flips it, 3 times a number, in this case the number is the letter n, is, and you could put is equal to, but is means the same thing, is equals, is 79. Now, when you're writing these, you can write the actual numbers with letters, right? But I think you get the idea. The next part is still giving you some examples, so kind of read over those. Here are the properties again. And so it's asking for you to solve the equation. So let's go ahead and look at one of these, for example, something like number 5. I know usually when there's a fraction involved, we get a little antsy about that. Well, in order to solve an equation, you have to isolate your variable. You have to get your x on one side and your numbers on the other side. Now, typically we try to get the x to keep it on the left-hand side of the equal. It's already there, so that would mean that I have to get the 7 over here on this side somehow. Well, if you notice, I use a real quick method that I call Mr. D. And so first you move the stuff that's on the wrong side. So I want my 7 over here. If it was since it is a positive 7 because there's no sign in front of it, we move it over to this side, it becomes a negative 7. Or some of you have perhaps added, you have a 7, so you subtract a 7 from both sides. Either method that you do will work. I use my Mr. D, so I already moved the 7. And then I rewrite this equation so that it can look pretty. So now the 7 already moved. I have negative 1/2 x is equal to, and I can do this really quick, 3 minus 7 should be negative 4. And so now I just do the last step, which is divide. What do you divide by? Whatever's here. So in this particular case, I'm going to divide, remember about the properties, you divide the same thing to both sides. So in this particular case, I'm dividing both sides by a negative 1/2. So that cancels. X is equal to, the good thing I see about here is I have a negative divided by negative, which automatically turns it positive. And division of a fraction is just easy if you think of it as multiplication. So what you do is you just flip this, take the reciprocal there, and then invert and multiply. So I just flipped it, and now I'm going to multiply. So 4 times 2 is 8, and then this is like having 4 over 1. 1 times 1 is 1. So there I get a positive 8. And therefore, that is my answer for that particular question. So now try the rest of these on your own. But let me do maybe one more, since it says solve the equation for the specified variable. So let's take any of these as an example. So let's try to do number 19. 19 says to solve for p. So that's what I have to isolate. I have to keep this by itself. So let's go and start the process. Well, whenever you're doing these questions, undo stuff. So right now, I don't want this r under here. So I'm going to get rid of it. The way to get rid of it is, remember, whatever I do to the left side, I do to the right. What happens if I multiply both sides by r? So this is not x, this is like a multiplication that you're used to, but just for demonstration purposes. See, if you multiply the left by r, you have r on top of r. Those cancel, so I end up with 3pq is equal to 12 times r is 12r. So I'm one step closer. I need the p alone, so I need to, since it's multiplied, do the opposite. Divide this side by 3q, divide this side by 3q. Whatever you do to the left, do to the right. Why? This will cancel these, and so I am just left with p is equal to 12r over 3q. But if you notice here, I could pretty much divide that out. So 12 divided by 3 is 4. And then you have your r on top of the q. There is how much p is equal to. So these take a little bit of practice. So now try the rest on your own.